At the Johnson Space Center in Houston, Texas, you can walk along a Saturn V rocket that was designed to help humans get to the moon. But now this center is helping NASA prepare for our next great adventure in astronomy, a telescope that will look way past the moon, out to the universe's farthest horizons. Here is the vacuum chamber that was used to test spacecraft during the Apollo era. So Lee, I understand it's being used for the James Webb Space Telescope too.
Yes, this is where we're going to be doing a full-scale test of the James Webb Space Telescope, including the telescope and the instruments, and we're going to be doing optical testing and thermal testing of those components.
Okay, we've seen tests before, but this is like the largest scale that we've done so far on Webb, right?
Yeah, in fact, it's probably the largest optical test that NASA has ever done, and that's because Webb is the largest space telescope we've ever built. So we're going to be testing the full primary mirror, which is 6.5 meters in diameter, and we're going to be testing the whole telescope and the instruments with it.
Okay, so before we get in there, give us a preview of what's been done to prepare for this test right now.
Well, first of all, this is the first test where we actually have flight hardware. It's the Aft Optics System, which is part of the telescope itself. We put the Aft Optics System onto the Pathfinder telescope, which is a model of the telescope and includes primary mirror segments on it. We then put that Pathfinder telescope with the Aft Optics System onto a large structure and a rail system that allowed us to put it in the chamber.
So what's the real purpose of the test?
We're going to be cooling the telescope down, and we're going to be making sure that all of the mirrors are aligned the way they're supposed to be, and also that the system as a telescope really works the way we expect at the very cold temperatures that it'll be at in space. It looks like they're all set up for the test, so let's get out of the chamber now. Now they're going to be closing the chamber door. The liquid nitrogen is used to cool the inside of the vacuum shell to about 70 degrees above absolute zero, but inside of that is a helium shell. The helium shell is what cools us to even colder temperatures to the 30 to 50 degrees above absolute zero. We're now well into the optical testing.
So what do you mean by optical testing?
We actually put light through the entire telescope chain, including the tertiary mirror and the fine steering mirror. Do you want to see some of the images from that's gone through the entire telescope?
Oh yeah.
Yeah, let me show you that.
Great.
We actually simulate what looks like little stars running through the entire end-to-end telescope, and by looking at how these stars go through focus, we can understand what the telescope is doing.
So that's how you test the end-to-end telescope through the full light path. How about the primary mirror alone?
We use special test equipment that lets us test the primary mirror just by itself, and by doing that we can determine the alignment of each of the mirror segments individually, but also how they relate to each other and to make sure that they're aligned properly. When we have the full telescope, we'll have 18 of these hexagons. Pathfinder only has 2 mirror segments, but it's enough to really let us practice all the things we need to practice in terms of the testing and the alignment.
The images look like they have fingerprints on them?
Yeah, so those fingerprints are really contour maps, kind of like taking slices through a mountain. Mm-hmm. As we tilt the mirrors around, the contour maps tell us how much the mirrors are tilted.
Okay.
And we use that information as we align the primary mirror.
What's the deal with this dark line right here through one of the primary mirror segments?
Yeah, so that's just a shadow from the big strut that holds the secondary mirror.
Oh.
Remember, the secondary mirror is on a tripod,
yeah.
And so the light that is hitting the mirrors is actually going and casting a shadow from that strut. And what we're trying to do is align the mirrors to create essentially a single mirror. Okay, so we're finishing up the test, and what we're doing is sort of reversing the process of getting it in. We have to be very careful with all the sensitive hardware, including flight hardware, that we're removing.
Well, thanks, Lee, for your time and letting us see what the first large-scale test on James Webb has been like.
You're very welcome.
The Aft Optics System has been removed from the test setup and will be joining other flight hardware for more testing at NASA's Goddard Space Flight Center in Greenbelt, Maryland. Thanks for joining us for this edition of Behind the Webb.